Okay, let me see whether I can share my screen. Ooh, window share. Okay, good. Can you see my screen?
Not yet. There it goes.
Yeah.
It's coming
Okay.
through. Yep, you're open.
Okay, great. So I have, let's see, about 8 minutes. I will say maybe 10 minutes or so. I will give you a quick overview of the VisionEval or VELandUse work I've been working on as a project supported by the SPR funding. So for those of you not familiar with VisionEval, it's a strategic planning model or tool that's originated actually at Oregon DOT by Brian Greger, like maybe 2 decades ago, and has since evolved into a suite of tools that's being used not only here in Oregon. For example, the Oregon Transportation Plan work that has utilized VisionEval for the modeling and visioning and modeling piece. And by many MPOs and DOTs throughout the US. It has a modular structure. So here our project focusing on specifically the land use package, land use module. And the goal of the project, of course, is trying to upgrade the land use model so it can support a wider range of scenarios and policies, both land use and transportation policies. And of course, it's mentioned already, it's supported through the SPR program. In terms of specific objectives for the project, we hope to basically utilize the best and latest data source for model estimation, and potentially also make the data available for other users of VisionEval. So we looking because the last sets, many of the VisionEval model has been estimated basically rely on 2001, some 2009 NHTS and older vintage of data source. And then beyond that, we hope to enhance a number of features in the existing VisionEval land use module, including kind of bringing in a real geography to so-called B zones, the primary geography representation in VisionEval, and then make those B zone allocation of both dwelling units and employment sensitive to transportation facility and service level. And finally, we hope to support use cases at different scale and level of specificity. So a range of different use cases depends on how much control the user wants in terms of the land use piece. Okay, finally, we hope this new module will be a drop-in replacement of existing VELandUse and VSimLandUse module. In terms of the data source, here we draw from a dozen or so nationwide data source range from census data to NHTS, Smart Location Database, LEHD, HPMS, National Transit Database, and so on and so forth. On the right is basically a diagram that shows the dependencies of those different data sources. I do not expect you to be able to read the letters there. They just show the dependencies, and we use a automated pipeline that be able to manage the dependencies whenever we basically need to go back and then fix an error or add a new additional variables. the pipeline will basically recognize, okay, I will need to update those intermediate steps, dependencies to refresh the data. So this is a project with a pretty much so far is the project I have been working with the largest data volume by far. So since each of them is a nationwide data set, and then we do not want to basically manually manage those updates and dependencies, and that process has been working pretty well for us. For the actual implementation, we draw heavily from existing work at ODA and also the existing VisionEval work, particularly the land use classification. We largely borrowed and adopted basically the definition that's been used in the place type. The idea is to divide or classify the land use into three diagonal dimensions, including land location type, area type, and development or diversity type. I will not, given the limit of time, will not go into details, but we basically bring a data-driven approach, use basically machine learning methods to help us come up with a consistent definition. I rely on either census or NHTS plus smart location database to help us come up with those different definitions. For example, location type, census does define or classify a census block into urban and rural, but the definition changes every decade so that we don't have a consistent definition of those urban-rural division. So we basically feed a random forest model that help us come up with a consistent definition of those urban-rural block group. And similarly for area type, I will go into a bit more detail in the following slides. So location type, we come up with our model actually fit the data pretty well. Has a accuracy of 94 to 95%, depends on which metric that you looked at. And then here, of course, the figure on the left shows the observed predict pattern for Corvallis, and then it matched pretty closely. For area type, we use a shallow decision tree, and then the method select not only the variables, but also the split, and then we go in and then label each of those different so-called leaf nodes as one of those area type, center, inner, outer, and fringe neighborhoods. And for diversity type, a similar method, but here it picked up the so-called D2A, job per households within 2-mile buffer, and then find out what the best split that defines or separate those different census block group. And in the end, we have a land use type classification that for basically every census block group in the US. This is a map that shows those definitions for or classifications for the Portland area. And we then implement 5 new modules in addition to 5, I believe, existing modules. It will work together with the existing VELandUse module. And then the user can then mix and match, basically, set up their input and then adds different modules to their RUM, VisionEval RUM sequence. So to support different use cases, the first one has the highest level of specificity. User basically dictates where dwelling units and employment goes to. The second has a bit more flexibility. The user specify the land use type for each census block group or so-called B zone, and then the model allocates those based on the specified land use type. Finally, the use case 3 have the most flexibility. The model predicts what the land use type will be and then allocate those employment and dwelling units. And finally, we run 3 basically hypothetical pilot applications using the Salem and Kaiser area as a case study. So we run 3 sets of scenarios: a hypothetical light rail line transit scenario, a scenario where we remove the coupler interchange, and finally a so-called V state application for the 4 counties surrounding Salem Kaiser area. So we are, as Josh mentioned, we are wrapping up the project, finalize the last bit of the report, and final touch on the package, basically our package. So the project would not be possible without the collaboration with Brian Greger, the management of the project of Josh, and then our members of our technical advisory committee. And the code is currently available on our own repository. Eventually, we'll move to the official VisionEval repo. And if you have any questions, feel free to reach out to me. And then if you have any quick questions, I'm happy to answer those too here. Thanks.